In this video, we have two trigonometric identities to establish or prove or confirm, different ways to say it. And we're going to be using some angle sum identities, these right here. The sine of A plus B is given by sine of A, cosine of B, cosine of A, sine of B. And then the difference, the sine of the difference of A and B, you can see the difference there. Instead of a plus there in the middle, it's a minus. That's what we're going to be using to prove these two identities. The standard procedure to solve or prove an identity or establish an identity is to start with one side, either the left or the right, it doesn't matter, whichever seems easier to you, and show that it gives you the other side. So I'm going to start with the left side. I have the sine of A plus B over the sine of A minus B. And all I'm going to do here is really just use that formula, those formulas I just showed you, just expand this. The formula, one of the formulas tells me, the first one, that if I have the sine of a sum of two angles, it'll be the sine of the first angle, okay, times the cosine of the second angle, cosine of B. And then it's plus, and then it's the cosine of the first angle, and the sine of the second one. And the same thing in the denominator, except there's a difference here, so I get the sine of A, cosine of B, and the only difference here is now it's a minus here, and then it's the cosine of A times the sine of B. And the good thing about proving identities is you already know what the answer is. You know your objective. I start with one side, in this case the left side, and I want to get this side. So the problem here is, okay, how can I get this expression here to come up with this? Well, we know that tangent of A is sine of A over cosine of B. Tangent of B is sine of B over cosine of B. So what we're going to do is we're going to divide the numerator and denominator by whatever it takes to get tangent of A up here. I need a sine of A over the cosine of A. Well, I already have a sine right there. I've got to get rid of this cosine here. So I'll divide the numerator by the cosine of A times the cosine of B. Let's see if that does it. Cosine of A over sine of A. I'm sorry, sine of A over, I'm dividing here, so sine of A over cosine of A, that gives me the tangent of A. Gotta get rid of this cosine B. Well, I got cosine B here divided. That does it. And then on the second one, in the numerator, I need a tangent of B. Okay, so this cosine of A divides the cosine of A here. That cancels. I get sine of B over cosine of B. That's tangent of B. That's legal, as long as I do it to the denominator also. So I'm going to divide everything in the denominator by the product cosine of A, cosine of B. So it's this over this over this in the numerator, and then this over this, and this over this. So what do we have? Just to shorten this a little bit, I'm not going to write all the steps here, but you can see that for this one here, I divide sine A, cosine B. The cosine B cancels, so what do I get? I get sine of A, cosine of A. The cosine B and the cosine B divide out. And then I get a plus here. So in the second one then, dividing the cosine A, sine B by cosine A, cosine B, the cosine cancels out, and I get sine of B over cosine of B. In the denominator, dividing again by cosine of A, the product cosine of A, cosine of B, the cosine of B cancels, and I get sine of A over cosine of A. And then it's a minus, and here the cosine A and the cosine A cancel, and I get sine B over cosine B. And then in the next step, we just look at this and say, well, sine of A over cosine of A, that's tangent of A. And it's plus sine of B over cosine of B, that's tangent of B. Because sine over cosine is tangent. In the bottom here, denominator, cosine of A over cosine of A, that's tangent of A, minus, and then sine of B over cosine of B is tangent of B. So we start off then, sine of A plus B over sine of A minus B. Doing all of this here is equal to tangent of A plus tangent of B over tangent of A minus tangent of B. There's your information. You could start with the right side. Notice, tangent of A is sine of A over cosine of A. Tangent of B is sine of B over cosine of B. Same thing in the denominator. We could clear it of fractions by multiplying by the LCD, and if you simplify, you'll see that you're going to get this. Go ahead and try it and see which one you like better. All we're doing is simplifying. Once we write this as sine of A over cosine of B, and the tangent of B is sine of A, sine of B over cosine of B, and same thing with the denominator. Clear the fractions and you can show that you get the left side. And number 2 is probably the easier one. I got sine of A plus B. So we expand this. I'm using the left side. Let me put it this way over here. Sine of A plus B over sine of A. And this is just the product of sine of A and cosine of B. So we expand this. Sine of a sum of two angles A and B would be the sine of A cosine of B plus cosine of A and the cosine of B. I should say the sine. So I got sine of A, cosine of B plus cosine of A, sine of B, and that's all over sine of A, cosine of B. And I can divide through here. But this is going to divide this out here. Sine A, cosine B. That's to give me a 1. And then I had to divide the cosine A sine B. So I'll do it this way. Cosine of A over sine of A, that's cotangent of A. And then sine of B over the cosine of B, the sine of B over the cosine of B, that's tangent of B. So again, the sine A cosine B divided out to 1 on this first one. And then when I divide the second two terms, the sine of A into the cosine of A, I get cotangent. And then the cosine of B goes into the sine of B to form sine of B over cosine of B. And that's your tangent of B. And that's your verification for that one. Thanks for watching. We'll see you next time.